Good morning, or good afternoon, or even good evening, depending on where you are. Welcome to this webinar organized by Eijkelkamp North America in the CPT webinar series. Today, we're going to talk about the Cone and Friends, a great partnership. I now would like to introduce Troy Chips, the CEO of Eijkelkamp North America. Troy?
Thanks, Gerald. I appreciate it. Well, as Gerald mentioned, my name is Troy Chips. I'm with Eijkelkamp North America. We're excited to bring you the 11th webinar already. Well, as Gerald, he is our technical advisor for CPT. And, you know, we were talking about the last two webinars that we did. We covered Seismic CPT, which is a module that is pushed into the ground with the CPT cone. And I was thinking, you know, maybe it's time that we talk about the other modules that we have that you can push into the ground behind the cone as well. So Gerald has put together this presentation, talk a little bit about the different modules that you can add to the CPT. With that, Gerald, take it away.
Thanks, sir. What we're going to talk about today is what I've entitled Cone and Friends, a great partnership. But before we do that, let's just first talk about the cone itself for those of you that are new to this webinar series. Most of you have seen this graph before. It comes back time and time again. Just to very quickly describe what cone penetration testing is all about. As you can see on the right-hand side, with a truck, but it could be with a crawler or with a standalone pusher or even with on the back of your drill rig, you push a cone into the ground at a standard speed of 0.8 inches per second or 20 millimeters per second. And at the end of those rods that you push in the ground, there's a cone that's enlarged, and you see there that we measure the tip resistance indicated by the red arrow, the pore water pressure by the blue arrows, and the sleeve friction by the green arrows. And then also the inclination of the cone a little bit with a sensor above that. Now, what is important to remember is that this cone is very standardized. Not only is the rate in which you push the cone into the ground standardized, but the dimensions, whether it's the diameter, whether it's the length, all these things are very standardized. And we do that so that we get a standardized test that creates the same type of results, whatever cone you're using. And then obviously, when you push that cone in the ground, you get these initial results, the tip resistance in purple, the sleeve friction in orange, and the pore pressure, or better, the dynamic pore pressure, because as you push the cone into the ground, there are some dynamic effects, and you get the dynamic pore pressure in blue. The so-called squiggly lines, as Paul Main at Georgia Tech used to refer to them. And what do we do with those parameters, those readings? Well, one of the things that we do with them is to correlate the different readings that you get. What you see here are two charts. On the vertical axis, it's the tip resistance. And then on the horizontal axis on the left side, it's the friction ratio, which is nothing more than the sleeve friction over the tip resistance as a percentage. And on the right-hand side, we put the pore pressure on the horizontal axis. And what Robertson and Campanella have done is develop these charts where you see a whole bunch of different areas that are numbered. And those areas indicate not what type of soil per se the cone is seeing, but how the soil where the cone is going through, how that soil behaves. And that's why they call it the soil behavior type. And if you are, say, in section 6, you are dealing with a sandy silt or to a silty sand. Why is it relevant? Well, when the pile or a foundation goes into the ground, the foundation can care less what type of soil it is per se. What it wants to know, what is important for its functionality, is how the soil behaves. And that's why the soil behavior type is very important. And then, of course, what you can do as well with all these parameters that you get, your tip resistance, your sleeve friction, your pore pressure, you can come up with all kinds of other soil parameters. And a good document to derive those soil parameters and what equations to use is this document by Peter Robertson, which you can find free on the internet. But if you want to get a copy, please feel free to contact me, and I'm more than happy to send you a copy. Now, why do I sell this stuff? That is what the cone does. But if you want more information, additional information, you can put on the back of the cone all kinds of modules. And together they will give you more information, basically for the same amount of effort, because you still push these devices together into the ground. And that's why we say Cone and Friends is a great partnership. Once again, not to replace the cone, but to complement the cone, so that you get an additional set of information that gives you some stuff that you can work with. The first one that I want to summarize fairly briefly is the seismic module that Troy already mentioned. And what you see here on the right-hand side is again the same cone. We do exactly the same thing that we do with a normal cone, but then on the back of the cone, we put a seismic sensor in the seismic module. And what you now do is, as you are pushing the cone in the ground, you stop at regular intervals, say every meter or so, create a seismic wave by hitting that green plate that is shown underneath the cone truck, and the plate is also shown in the picture on the left. You hit it horizontally to create a shear wave, and that shear wave, as it travels through the ground, is then recorded by the seismic sensor. Since you know when you created that wave, and you take a recording over time from your seismic sensor, you're going to get more squiggly lines. And what you see here on this slide is basically a summary of the 3 steps that we go through to analyze this data. On the left and in the back, you see the recorded traces, and you can kind of see that as you go deeper, because it's the top 2 lines are at 1 meter depth, the X and the Y, and then 2 meters and 3 meters. But as you go deeper, you kind of see that it takes more time for the seismic wave to arrive at the sensor. What we do then in the chart in the middle is basically extract the seismic feature of this whole thing, and you see that we've only taken there the y-axis, and on that basis you now calculate the arrival time of the seismic wave, and that is shown in the chart or the table on the right hand side. We can also get the interval velocities, the shear wave interval velocities. That's how you basically analyze the seismic data. Shear wave velocity, you can also do it for compression wave, which is a different type of wave. And those 2 data together are again giving you a lot more information about the soil properties. Because if you have the shear wave velocity and the density of the soil, you get your shear modulus. Once you have your shear modulus, you have a fairly decent idea what your Young's modulus is, because it's basically a little over 2 times the shear modulus. And if you have both the shear wave velocity and the compression wave velocity, what you see there on the bottom is you can get your Poisson ratio. And of course, with the Poisson ratio, as you see in the line above that, you can get a more accurate assessment of the Young's modulus. So with these additional bits of information, you basically get a better feel for what the soil parameters are all about. The seismic module can be combined with any type and any size of cone. So if whether you use a 10 centimeter square cone or a 15 centimeter square cone, a subtraction or a compression cone, it doesn't make any difference. You can put it on the back of that cone and combine it with that. And as mentioned before, webinars 9 and 10, the ones that we did in January and February, provide you with more information, and you can find them on the Eijkelkamp YouTube channel. And if you have any more questions about it, please feel free to let me know. So that's the seismic module. The second one that I want to talk about is the magnetometer module. And what you see with the magnetometer module, what you can do is basically illustrated at the little figure that I pulled of the internet on the bottom right. Anywhere around the world, you have a magnetic field, and those magnetic fields are in standardized orientation. But if you now have some buried pieces of metal, that magnetic field will get affected, will get distorted. And basically, what you do is with a magnetometer, is you measure the direction and the strength of the magnetic field. And as I mentioned, if you have ferromagnetic material, that creates a disturbance of the magnetic field, and that disturbance is then picked up by the magnetometer. And the magnetometer module is basically nothing more than part of a rod with this magnetometer inside. Typically used to detect buried or submerged objects, but it could also detect metal objects that are installed below grade. Think of a sheet pile that you have in the ground, or a steel H pile, or even a reinforced concrete pile. You might even be able to pick up the reinforcement as you push that magnetometer into the ground with the seismic or with the CPT count. Basically, the magnetometer will detect objects within a radius of about 2 meters. So if you push the cone in the ground, then you have a cylinder with a diameter of 4 meters, or about 14 feet or so, where you pick everything up. And this method has been utilized for all kinds of things. So on the right-hand side right now, you see the resulting lines of the three sensors. Basically, you do it in the X, Y, and Z direction, and then also a resultant for a buried metal device. And you can kind of see where that device is located. It's at about 4 meters below grade. But it can also be utilized to, as you can see here, for the determination of the length of a foundation or a sheet pile. Now, you can also use it for positioning or finding the position of a tieback anchor or a other anchor, or even power cables. Now, as long as you have ferromagnetic metal into the ground, you can detect with the magnetometer its presence. What is nice about this device, though, is when you use a magnetometer at the surface, you will only go so deep. And obviously, if you push the cone in the ground, you might go to 20, 30 meters deep. And at that depth, can then use your magnetometer and detect any metal parts there. So that's kind of in a nutshell, what the magnetometer module does. Different than with the seismic module, it does not provide any additional information about the soil. And as such, it's kind of different, but I still thought it's useful to mention here. And you can combine it with any 15 centimeter square cone or with a dummy cone. And if you are concerned that you don't really need the soil data, it's probably easier to use a dummy cone, because the dummy cone is cheaper. And if you then break it or lose it, the loss is at least more limited. So that's the magnetometer module. That was module number 2. Third one is the video module. And the video module is nothing more than a camera that records the soil as it passes by the lens of the camera. For many, it is still important to be able to see what kind of soil you have. It's important that they get a feel for the particle sizes and so on, the color and all kinds of good stuff. And since CPT does not bring any samples to the surface, this could be, for those people that really want to see that, be a good tool. You still don't bring anything to the surface, but at least you get this information. On top of that, if you don't use standard light, but you use ultraviolet light, you can also use this module to get an indication of the presence of hydrocarbons because of fluorescence activity. You see already a screenshot at the bottom. What you see in there is basically how the software works. On the left-hand side of the chart, you see the CPT squiggly lines. At least the blue, the red, and on the right-hand side also you have the inclination in there. Then you get on the center some kind of a boring log, and then on the right-hand side you get the image that is in front of the camera. Going a little bit larger, what couple things that I want to highlight there is you see at the top left-hand corner a black horizontal line. that shows you where the camera is at that time as you play this video, because since you're pushing the cone into the ground with a certain speed, it's probably too fast to view all this stuff in real time. So it's better that you play it back afterwards, somewhat in slow motion. So the black line gives you an indication where you are. The middle, again, is the kind of the bore log, and it gives an indication what is being shown by the two horizontal white lines. And on the right-hand side, you see the image itself with the depth clearly shown. And what I will do right now is change, if everything goes well here. Oh. You should be able to see now this video. And as you see on the right-hand side, it starts to move down. You're now at 0.11 meters, 0.12, so you definitely don't do this necessarily in real time. And also very, very slowly, what you see on the right-hand side is that the black arrow is starting to move down as well. But you see how slowly that goes with the black arrow. But on you get a better feel on the right-hand side, and you can see kind of the color of the soil. You can kind of see the particle size. At least you get an indication of what's there. And you also see in the center how that the horizontal white lines are moving down to give you an indication where you are in your bore log. And this way you can then go down in the whole thing. Now, remember, we're now about a minute down. We're only at about 21 centimeters. So it's definitely not going in real time. And if you want to look at 20 meters or so of soil, it will take you a little bit of time, but at least you have that capability to view all that stuff. So let's go back to the PowerPoint presentation again. That's the video module, and that gets you an idea of what the soil is all about. Once again, just like the seismic module, it does provide you with additional information, and the only requirement is that it can be combined, or has to be combined, with a 15 centimeter square cone. And it is simply to provide sufficient space inside the module to put the camera and all the associated instrumentation in there. So it's a step module. Next one that I want to talk about is the connectivity module. And basically, you see that module there on the right-hand side of your screen. And basically what that module does is that it measures the electrical parameters of the soil, which is the electrical conductivity or electrical permittivity, depending on how you look at it. And it varies as a function of the soil water content. It also varies as a result of contamination with hydrocarbons. And it also is related to, inversely related to, the particle size. Clays generally have a higher conductivity than sands. And what you do with this whole thing is that you see there those two rings, and basically those are being charged with different voltages, and then the current is going through the soil from one ring to the other, and that then gives you how you can measure that resistance. One big warning though, this device generally works only in fresh water. If you have very salty water, the conductivity is too high and you short out the device. And that's not what you intend to do, undoubtedly, but keep it in mind, you need to go to basically in fresh water where this device works. And just an indication again of some of the results that you're going to get in here. You see that if you talk about sand to clay and silt in between, it is an order of magnitude difference in the electrical conductivity. So it gives you, if you measure the conductivity, it gives you a better indication of where you are. If you don't necessarily believe the soil behavior type, that's how the soil behaves. here now you get an indication of what the soil actually is, whether it's a sand, a silt, or a clay, just by looking at your conductivity. Once again, it does provide additional information on the soil properties. So it's again a complement to the information that you get from your cone. And it can be combined with any 15 centimeter square cone or even with a dummy cone. Once again, just like with the magnetometer module, if you feel that you don't need the CPT data, you can put a dummy cone in front of this whole thing and push the conductivity module all by itself. So that in a nutshell are some of the modules that I want to talk about today. There are others. There are many others there that we could be talking about, but these are some of the main ones that are probably used the most often. A couple of comments though, and that's why I don't want to introduce others. I want to talk about a little bit about in general terms about these modules. What you've seen, most modules require a 15 centimeter square cone. Simply because of the items that you want to put in these modules, you need some space. And if you go to a standard 10 centimeter square cone or a 36 millimeter or a 1.44 inches diameter cone, you don't have enough space. And that's why most modules require a 15 centimeter square cone. In and of itself, no big problem, because as I mentioned before, if you want to push a cone in the ground and you want to get as deep as possible, a 15 centimeter square cone with the standard 36 millimeter or 1.44 inches diameter rods will get you the deepest with a given push force that you have at the surface. So that is no problem. One thing that I often hear people do is they say, okay, Gerald, it's great. I just buy a whole array of modules and then I just connect it to my cone whenever I need one. Yes, that can be done, but it's not recommended. The connection between the module and the cone is generally a little bit more sensitive. It may be some more sensitive wiring. And so my strong recommendation is that if you buy a module, buy a cone that goes with it, keep the module and the cone together, and use it whenever you need it, but don't just detach a module and hook it back up again when you need it. If you do have cones already, it's no problem to get those to us and we'll mount the module on top of that existing cone. But my recommendation is to keep it together. The other thing is, and that's the one that I mentioned in the last line, something that's fairly obvious, of course, modules cost money. Yeah, nobody will be surprised about that. But my recommendation is only push those modules in the ground when you need them. Even if you're very experienced, even if you're very careful, you are going to lose a cone every so often when you push the CPT cone. And the less money you push in the ground, the better it is, because you never know whether the day that you're going to lose a cone is the day that you're actually now working with one of those modules. So if you push a module in the ground, you push more money in the ground, and therefore only do it when you really need it. That's from a financial point of view. The other thing, though, to also keep in mind is that using a module makes it a little bit more complex. As many of you will know, when you do CPT, before and after a sounding, you need to do a baseline survey to make sure that your cone is in calibration before you start and that it hasn't gotten damaged as you perform your sounding. And whether you have a normal cone, which is about, say, a foot long or 30 centimeters long, if you now put a module behind it, that makes it a little longer. And therefore, it's a little bit more complex, a little bit more of a hassle to do those baseline surveys before and after the sounding, because it has to be free hanging. That means it cannot touch the soil yet. And obviously, if you have a longer device, you need more space underneath your clamp to do that. And that may be sometimes a little bit of a hassle. So that too is a good reason to only use a module when you really need it. So with that, basically come to the conclusion that cones, whether it's a 15 or 20 or 15 or 10 centimeter square cone, a subtraction or a compression type cone gives you very good information, very useful information, but you can get additional information from the friends of the cone that you can put on the back. Since as you are pushing it together with the cone, it takes the same amount of time, the seismic cone being an exception because you need to interrupt your process every so often. But for the video cone and the magnetometer cone, it's the same amount of time. You collect all your data and you get additional data, additional information during that same sounding. So my strong recommendation is use them whenever you require more information than only the basic readings of an electrical CPT cone. With that, we've come to the end of this webinar. Seen a few questions that have come in. Basically, the first question was, can you give us a clear information about the pricing of some of the modules? I could, but there are too many variables in there. So I would strongly suggest that you basically get with the Eijkelkamp sales staff or get back with me for a specific type of module that you would like us to talk about, and I'm more than happy to give you more specific information there. Then there was a question about the video cone. Is there a computerized solution for estimating the mean particle size from the video module data? Right now there is not, but we're working on that, and probably by later this year, maybe early next year, we hope to have a much better software to analyze the data. Basically, what we are intending to do is use computer artificial intelligence to really look at these pictures and then come up not only with the size of the particles, but also with what type of soil it potentially is, and other parameters that you could possibly derive from this. But right now, what you have there is basically just the image itself, and from the scale of the picture, you can determine what you have. One other comment, though, personally, the mean particle size may be of interest on certain situations, but quite often, to me, the foundation that goes into the ground doesn't really care what the mean particle size is. And I keep mentioning this about the foundation going into the ground. That is really the most important part. But to me, we're not doing CPT to come up with all kinds of interesting information about the soil. What we're trying to do is being practical and predict what the bearing capacity is for a foundation. And therefore, I keep coming back to, let's just look at it, what is important for the foundation. And what is important there is really how the soil behaves. And true, if you see very large particles, really large boulders in there, then obviously you need to stop almost straight away, because then you have a good chance that you're going to damage your cone as you push it deeper in the ground. But that could give you some valid information. So you need to weigh what you're trying to do, and it does not always. There's not necessarily a very straightforward answer, but think about what you really want to get out of this whole thing before you get started with it. And with that, unfortunately, I've come to the end of the half hour, and we've tried to keep these webinars to the duration. Once again, thank you for your presence. You see my telephone number, you see my email address. If you have any questions, please feel free to contact me by phone. You can also use that number through WhatsApp or by email. I'm more than happy to talk to you about it. Thank you very much.